Okay, so we all talk about the cloud, right? We use it every single day, probably without even realizing it half the time. It's
hmm
just there, this invisible thing powering the internet.
It really is.
Yeah.
But, if you go back a bit, the term itself started, well, much more simply.
How
It
so?
was literally just that little cloud symbol you used to see in network diagrams, like years ago.
Oh, yeah, I remember those. Representing the network, the internet part you didn't need to worry about the details of.
Exactly. It just represented, the complex stuff happening somewhere else, the infrastructure moving data around. And it's a metaphor that's really stuck
Yeah, it has.
because fundamentally, cloud computing is still that, a hidden, vast network of hardware, storage, services, all delivered like a utility on demand.
Like electricity. You plug in, you get power, you don't necessarily need to know about the power plant itself.
Precisely. You care about the service, the capability, not the underlying machines.
Okay, so it's way more than just storing your photos online then.
Oh, absolutely. Way more. We're talking about delivering almost any kind of computing function, software, platforms, raw infrastructure, storage over the internet.
And it's tailored to what you need when you need it.
That's the key. It's driven by user demand. You can get a whole platform to build applications on, or just a specific piece of software, or just storage. It's incredibly flexible.
So who are all the different people involved in this? It sounds like a big ecosystem.
It is, yeah. You've got the end users like us, or businesses.
Yeah.
For many, especially smaller businesses, the cloud provider kind of acts like their outsourced IT department.
Right, handling the tech stuff.
Then there's the business management side within those companies. They're focused on things like governance, security, managing costs within the cloud.
Okay.
And then, of course, you have the cloud service providers themselves, the big names we know. They own and manage all the physical hardware, the data centers, the networks. They keep it all running.
So it's this interaction between users, the business side, and the providers. Now, our notes highlight 4 basic characteristics that really define cloud computing. First up, elasticity and scalability. Why are these so fundamental?
Well, think about how demand changes. An online store, for example. Black Friday versus a random Tuesday afternoon. The computing needs are wildly different,
Like, they're
right?
totally different. Huge peaks.
Exactly. So elasticity is the cloud's ability to stretch or shrink resources almost instantly to match that demand. Scalability is related, but more about handling growth over the long term.
Our sources use a nice analogy, a rubber band. It fits whether you're holding a few pencils or a big stack of papers.
That's a perfect way to think about elasticity. It adapts in real time.
Okay, and that connects to the next point, self-service provisioning.
It does. Because that elasticity is often paired with the ability for users to request resources themselves on demand. No more waiting weeks for IT to set up a server.
Ah, right. You just go to a portal, click a few buttons, and boom, you have what you need. Almost like a vending machine for IT stuff.
Kind of, yeah. And crucially, there's also automatic deprovisioning.
Meaning it automatically gets rid of resources you're not using anymore.
Exactly. So you stop paying for them. It's about efficiency. But, as the notes rightly say, even though it's on demand, you still need to plan what you need. It's not magic.
You still need to know what button to press on the vending machine. Okay, third characteristic, APIs. Application Programming Interfaces. Sounds technical. Why are they so vital?
Think of APIs as like universal adapters or translators. They provide a standard way for different software applications, maybe from different companies even, to talk to each other and exchange data.
Okay, like how?
Well, imagine your sales team uses one cloud tool, say a CRM, and finance uses another for accounting. APIs let those two systems share information, automatically sales data flowing into financial reports, for instance, without needing complex, custom-built bridges every time.
Got it. So they enable different cloud services to actually work together smoothly. Makes sense. And the final one, pay-as-you-go billing.
This is pretty core to the model. You're billed based on your actual usage, often metered very precisely, like by the hour or even minute for some services. It's like your utility bill.
Pay for what you use. But what about free services? Our notes mention even those are metered.
Yeah, that's interesting. Even if a service is free to the user, the provider is still tracking how much resource it's consuming behind the scenes.
Why?
For capacity planning, understanding usage patterns, maybe identifying when a free user might need to upgrade to a paid tier. It's valuable data for them.
Right, okay. So that gives us the groundwork. We've got these notes, some research, and our goal for this deep dive is really to unpack cloud computing, get under the hood, understand its core ideas, how it evolved. So let's dig back into those characteristics. Elasticity, that rubber band idea is good, but what's the real impact compared to the old way?
Well, the contrast is stark. In traditional IT, you had to buy enough hardware for your absolute busiest moment, your peak load.
Which means most of the time, a lot of expensive equipment was just sitting there underused.
Exactly. Massive capital expense, often wasted. The cloud, with its elasticity, avoids that.
Hmm.
It's not just about adding servers. It's the automation. Systems can scale up or down automatically, responding to demand without someone manually intervening. That's huge.
And scalability handles the longer-term growth.
Right. Scalability means the service can grow with your needs, more users, more data, without requiring a fundamental redesign. It's designed for growth.
And that self-service provisioning,
Yeah.
it feels like more than just speed. It changes who gets to control IT resources, doesn't it?
Absolutely. It democratizes access. Think about it. Before, a marketing team needing resources for a campaign, they'd file tickets, wait for IT, approvals, procurement,
Yeah.
weeks, maybe months.
Yeah, whole process.
Now, with self-service, that same team can often spin up what they need, servers, databases, through a web portal in minutes. And the automatic deprovisioning means they don't accidentally leave things running and rack up huge bills after the campaign's done.
It makes IT much more agile, responsive to the business.
Definitely. Much more.
Okay, and those APIs, those universal translators, can we make that even more concrete? Give me another example.
Okay. Think about booking a flight online. The airline's website needs to check seat availability, process your payment via a separate payment system, maybe even connect to a hotel booking system if you add that.
Right. Lots of different parts talking to each other.
Exactly.
Hmm.
APIs are the contracts, the defined ways those different systems communicate. The airline system doesn't need to know the internal details of the payment system. It just needs to send the payment request in the agreed API format. It's what makes all these interconnected online services possible. Without standardized APIs, it would be chaos.
That flight booking example really clarifies it.
Okay.
And digging into pay-as-you-go, the fact that even free stuff is metered, you said it's about data for the provider.
Yeah, it highlights how data-driven these services are. Metering usage, even on free tiers, helps providers optimize their infrastructure, understand how people are actually using the service, spot potential abuse, and figure out when someone might need more than the free tier offers.
So free isn't really free. It's often a data exchange, in a way.
You could certainly look at it like that in many cases. It's part of the business model.
Okay, so let's try to pin down a definition. If you had to give a concise definition of cloud computing, what would it be?
At its simplest, it's using computing resources, processing, storage, software, whatever, delivered as a service over a network, usually the internet. And that name comes from that cloud symbol in diagrams, hiding the complexity.
Right. And our sources pull out three things that really set cloud apart from just, say, traditional web hosting. What are those?
Okay, first, it's sold on demand, often billed by the minute or hour. Very granular. Second, that elasticity we talked about. You can scale up or down significantly, almost instantly.
As much or as little as you need.
Right. And third, it's fully managed by the provider. The user just needs, a computer or phone and internet access. The provider handles the underlying infrastructure, maintenance, everything.
And what really pushed cloud computing forward, it felt like it exploded relatively quickly. What were the key drivers?
It was definitely a convergence. Big advances in virtualization technology were key, getting more out of the hardware. Distributed computing concepts provided the blueprint. Then, crucially, high-speed internet became widely available and reliable.
Making it practical to deliver services remotely.
Exactly. And then there was the economic driver businesses, looking to cut down on huge upfront hardware costs and ongoing maintenance. It just made financial sense for a lot of use cases.
So it's not just about outsourcing IT. The notes suggest a broader way to think about it. What's that?
Yeah, a wider lens focuses on the location. Cloud computing is fundamentally about delivering computational resources from a location different from where the computing is actually consumed, accessing power from somewhere else over the network.
Decoupling the user from the physical hardware.
Precisely.
And that has big implications for our devices and software, right?
Huge. You don't necessarily need a super powerful computer anymore or tons of locally installed software. So much can live in the cloud, accessed through a browser or a simple app. It changes how we interact with technology day to day.
And the payoff for the user? The consumer or business?
Lower upfront costs is a big one. You avoid that big capital expenditure on servers and stuff. It shifts to an operational cost pay-as-you-go. That lowers the barrier to entry for new businesses, too.
Plus, no need to manage the infrastructure yourself.
Right. Reduced operating expenses, no headaches, managing servers, power, cooling, and you can access your stuff from anywhere. Huge flexibility.
Okay, let's trace the history a bit. The notes say the term cloud computing has kind of fuzzy origins. Where did it actually come from?
It's interesting, yeah. It really seems to have grown out of that visual shorthand, the cloud icon, in network diagrams back in the 90s, maybe even earlier.
Just meaning the network or the internet.
Pretty much. A way to represent that complex part without drawing every single router and switch. Especially when telcos started offering VPNs, virtual private networks.
Ah, how did VPNs play into it?
Well, VPNs were an early form of shared infrastructure over the telco's network. They used the cloud symbol to show the boundary. This part is our responsibility. Inside the cloud, your part is outside.
So the cloud represented the provider's domain.
Right. And cloud computing just expanded that domain to include not just the network, but the servers, storage, applications too.
But the core idea of sharing resources goes way back, doesn't it? Like mainframe timesharing in the 50s.
Absolutely. That's a
Yeah.
key ancestor. Mainframes were incredibly expensive, so time sharing let multiple users connect via terminals and share the processing power. It was purely about economics, getting the most bang for your buck from that massive investment. The cloud then was that central shared resource pool.
And that economic driver keeps coming up. Professor Chalapa's quote from 97 that economics, not just tech limits, would define computing.
Yeah, that was quite prescient. It captured that shift. It's not just can we do it, but does it make sense financially? That's central to the cloud's appeal.
Now, is cloud computing truly new, or is it just like old wine in new bottles, like utility computing revisited?
That debate comes up a lot. There are definite parallels with utility computing paying for compute like electricity. But cloud computing today is so much more sophisticated. The scale, the self-service, the sheer breadth of services.
Mm.
It's a massive evolution of that concept, I'd say, not just a rebranding.
So what were the real milestones, the moments that kicked off the modern cloud era?
Well, Salesforce.com in '99 was huge, delivering complex business software entirely through a website, true software as a service. That was groundbreaking.
Showed it was possible.
Yeah. Then Amazon Web Services starting in 2002, initially with basic storage and compute. But the big one, arguably, was Amazon EC2 Elastic Compute Cloud in 2006,
Why was EC2 so significant?
because it made raw, rentable computing power accessible and affordable for almost anyone. Small businesses, individual developers. You can rent servers by the hour. That really opened the floodgates.
Okay, let's break down the different flavors of cloud services. Our sources talk about IaaS, PaaS, and SaaS. Infrastructure as a service, IaaS, is the base layer.
That's right. IaaS is like renting the fundamental building blocks. The provider gives you access to computing resources, virtual machines, storage, networking components like firewalls, load balancers, IP addresses. It's the raw infrastructure.
Managed by hypervisors, that's the software that carves up the physical hardware into virtual machines.
Correct. Hypervisors make that efficient sharing of physical hardware possible.
So if I use IA, what am I still responsible for?
You manage everything above the raw infrastructure. So you install and manage the operating system, the middleware, your applications, your data. You have a lot of control over the software stack, but the provider handles the underlying hardware.
And billing is typically utility style. Pay for the resources you allocate or use.
Generally, yes. Very much usage-based.
The notes also mention stay storage as a service as
Yeah.
part of IAA. What's key there?
It's just providing that scalable, on-demand storage capacity in the cloud, like a potentially infinite hard drive you access over the network. But it does bring up important questions about data security, reliability, who has access, these
Great.
things you need to consider.
Right. Makes sense. Examples include Amazon EC2, Google Compute Engine, Azure Virtual Machines. Okay, moving up the stack. PaaS, Platform as a Service. What's added here?
PaaS provides not just the infrastructure, but also the environment on top of it. So the operating system, programming language runtimes, databases, web servers, basically. A platform ready for you to deploy and run your applications.
So less for the user to manage.
Exactly. The big win for developers is they can focus purely on writing and deploying their code. They don't have to worry about managing the OS, patching servers, scaling the underlying platform. The provider handles that.
Like renting a fully equipped workshop instead of just the empty building.
That's a good analogy, yeah. And some PaaS offerings even handle automatic scaling of your application based on load.
That sounds really useful for developers. Examples, Heroku, Google App Engine, Azure Compute. Okay, top layer. SaaS, software as a service. This is the one most people interact with directly, right?
Definitely. With SaaS, the provider hosts and manages the entire application. You just access it, usually through a web browser or an app. Think of things like Gmail, Salesforce, Microsoft 365.
So you're just using the software. You don't install or manage anything locally?
Correct. No installation, no updates to worry about. A provider handles everything. It simplifies things massively for the end user.
And it scales easily.
Usually, yes.
Yeah.
Behind the scenes, the provider can run the application on multiple servers and use load balancers to handle lots of users, all transparently to you.
Our sources mention multi-tenancy with saws. What's that?
Multi-tenancy means a single instance of the software serves multiple different customers or tenants. Your data is kept separate and secure from others, but you're all sharing the same underlying application infrastructure. That sharing is key to making SaaS cost-effective.
Got it. And it's not just those three, right? The notes list DES, BPS.
Yeah, the as-service model has expanded. DES is desktop as a service, virtual desktops. BS is business process as a service, outsourcing specific processes. TEAS is testing environment as a service. KEYS is communications as a service. Lots of variations now.
Shows how flexible the model is. And how is saws usually paid for?
Typically, it's a subscription. A flat fee per user, per month, or per year. Predictable costs. Examples we mentioned, Google Apps, Office 365, even streaming services kind of fit this model.
Okay, good breakdown. Now, a point of common confusion, cloud versus grid computing. They sound similar. What's grid computing?
Grid computing is a form of distributed computing, specifically focused on harnessing lots of networked computers, often geographically dispersed, to work together on a single massive computational problem, like creating a virtual supercomputer.
Breaking down huge tasks.
Exactly, like analyzing astronomical data or complex simulations. Now, many cloud platforms use grid techniques under the hood for certain tasks, but cloud computing itself is broader.
Broader how? The notes mention BitTorrent or SETI at home as sort of cloud-like, but not quite the same.
Right. Those are distributed systems sharing resources, but they often lack the centralized management, the on-demand provisioning, and the commercial billing model that characterize modern cloud computing. Cloud evolved from grid concepts, but added those layers.
And things like Expedia. Where do they fit?
They're more like service commerce platforms, often built using cloud infrastructure. They act as aggregators, a type of SaaS or managed service provider.
So cloud came from grid, adding that on-demand aspect. But how do you clearly separate them? The notes say the user perspective matters.
Yeah, that's a good way to think about it. With a grid, users might still be quite involved in the infrastructure setup or job submission process. With cloud, the goal is usually to abstract that away. The user wants the service storage, an application, whatever. They don't necessarily care how the provider delivers it using grids or other tech.
So grid is about tackling one massive problem in parallel, while cloud is about delivering a wider range of services, abstracting the underlying complexity.
That's a pretty good summary, yes.
But they share things like scalability, load balancing, maybe multi-tenancy.
Definitely. Both aim for efficiency and handling load. They both distribute work, share resources, and usually come with service-level agreements, or SLAs, guaranteeing certain levels of uptime or performance.
The notes compare Amazon S3, cloud storage, with data grids. What's the difference there?
S3 is designed as a general-purpose object store, great for storing anything from tiny files to large backups, accessed via web APIs. Data grids are often more specialized, optimized for managing and accessing extremely large structured datasets used in scientific computing, maybe spread across different institutions, different focus.
And computationally, grids for heavy-duty stuff.
Often, yeah. Grids excel at those really intensive parallel processing tasks. Cloud providers offer various compute options, including high-performance ones, but their portfolio is generally broader, catering to web hosting, databases, general business apps, alongside the heavy compute.
Okay, that clarifies the grid versus cloud distinction. Now, let's talk virtualization again. It keeps coming up as absolutely essential. Why is it the cornerstone?
Because it's the magic that makes the resource sharing and dynamic allocation possible, really. It creates that abstraction layer, hiding the physical hardware's complexity.
Allowing multiple virtual machines on one physical box.
Exactly. Server virtualization lets you do that, dramatically increasing how efficiently you use the hardware. And storage virtualization pools physical storage, presenting it as a unified resource. It gives you flexibility and helps control costs.
So cloud discussions almost have to start with virtualization because it's the enabling technology.
Pretty much. It underpins the whole ability to deliver scalable, flexible, cost-effective services on demand. It applies everywhere: memory, networks, storage, OS, apps.
Our sources listed 3 key characteristics of virtualization for the cloud: partitioning, isolation, encapsulation. Can you recap those?
Sure. Partitioning is about running multiple operating systems or apps on one physical machine. Isolation means those virtual machines are protected from each other. One crashes, it doesn't take down the others. It also separates the software from the specific hardware.
And encapsulation.
That's packaging a whole virtual machine, OS, apps, data into a single file. Makes it easy to move, copy, manage.
Got it. Examples like virtual memory, using disk space, or software emulating a whole PC. These are everyday examples.
Yeah, virtual memory is a classic OS-level virtualization. And emulators, or VM software in your desktop, let you run, say, Windows on a Mac.
Yeah.
That same principle, massively scaled up, is what happens in cloud data centers, drastically reducing the number of physical servers needed.
And the software managing all this in the cloud is the hypervisor.
Correct. Hypervisors like the traffic cop for the virtual machines, allocating resources, keeping things separate. It's fundamental to making the cloud work efficiently and securely with diverse workloads.
Okay, let's switch gears to where these clouds actually live. The deployment models. Public, private, community, hybrid. Public cloud first, what's the definition?
Public cloud is what most people think of. Infrastructure owned by a provider like AWS, Azure, Google Cloud, and made available to the general public or businesses over the internet. You share the underlying hardware with other tenants, but your stuff is logically separate, usually pay-per-use.
The standard model. What about private cloud?
Private cloud is infrastructure dedicated solely to one organization. It might be on their own premises or hosted by a third party, but it's not shared with others. Offers more control, potentially better security or compliance for sensitive stuff, but it's more expensive and complex to set up and manage. It's your own personal cloud, essentially.
Sometimes called internal or corporate cloud. Does it always use the pay-per-use model?
Not necessarily. The internal economics might be different. It requires significant investment and expertise.
Okay. Third type, community cloud.
Yeah.
Less common.
Yeah, a bit more niche. This is where several organizations, maybe in the same industry or with shared regulatory needs, pool resources to create a shared cloud infrastructure. They share the costs and benefits. It's kind of a middle ground between public and private.
Shared by a specific group with common concerns. Got it. And finally, hybrid cloud.
Hybrid is a mix. It combines two or more types, usually public and private, keeping them separate, but connected by tech that lets data and apps move between them.
Like cloud bursting. What's that?
Cloud bursting is a classic hybrid use case. You run your application normally in your private cloud, but if you get a sudden surge in traffic, it automatically bursts out and uses resources from the public cloud to handle the peak load. Then it scales back down when the rush is over.
Best of both worlds, potentially. Using public cloud scalability when needed, keeping sensitive stuff private.
That's the idea. It's often good for less critical apps or those without super sensitive data. It can improve fault tolerance too, but it adds complexity managing resources across different environments, ensuring security is consistent.
So hybrid offers flexibility, but maybe less simplicity than pure public or private.
Exactly. It's a trade-off. You get scalability, but potentially more management overhead and complexity. Our sources actually have a diagram showing how these four models relate, which might help listeners visualize it.
Okay, this massive shift to cloud isn't just technical. It has ethical dimensions too, right?
Oh, absolutely. Huge ones. When you move to the cloud, you're fundamentally relinquishing direct control over your data and infrastructure to a third party.
And that data might be stored across multiple sites, maybe even multiple countries, managed by different organizations.
Precisely. And services often interoperate across networks.
Yeah.
This creates risks, unauthorized access, data corruption, infrastructure failures. And because it's so complex, figuring out who's responsible when something goes wrong, what the notes call deperimeterization, can be really difficult.
The problem of many hands, where responsibility gets diffused.
Exactly. It can obscure accountability. There's also the challenge to privacy and informational self-determination. When data is shared so widely, sometimes without explicit consent for every use, it impacts trust. Think about risks like identity theft.
Are there easy answers for managing these ethics?
Not really. It highlights the critical need for strong cloud governance, clear rules, regulations, standards. Accountability is key, knowing how data is handled and who's responsible. But there's often a tension between accountability, which requires tracking, and privacy.
And vendor lock-in is another concern mentioned? Being stuck with one provider?
Yes, that's a big one. Difficulty in moving your data or applications to a different cloud provider. Standardization efforts, like those mentioned from NIST, aim to mitigate this, but it's still a challenge. Plus, the potential for market dominance by a few huge players raises concerns about future pricing and policies.
Lots to think about there. Let's flip to the positive side, the benefits. Why are so many organizations embracing the cloud?
The biggest driver is often cost. Avoiding huge upfront capital expenditure on hardware and paying only for what you use. That shift to operational expenditure is very attractive.
And better resource use.
Definitely. Sharing resources in the cloud leads to much higher utilization rates compared to siloed servers. That reduces infrastructure costs significantly and lets developers build and deploy applications much faster. You're not constantly engineering for rare peak loads.
And faster internet made it all feasible.
Right. Widely available high-speed bandwidth was crucial.
So, for providers and users, what are the key benefits summed up?
Okay. Cost savings. Less capital expense, lower barrier to entry, potentially fewer in-house IT staff needed for infrastructure management. Scalability, flexibility, start small, grow quickly, scale back if needed, handle peaks easily. Reliability. Providers often have multiple redundant sites for disaster recovery. Maintenance provider handles updates and upkeep. Mobile access systems accessible from anywhere, boosting productivity.
So let's quickly recap the defining characteristics we started with now that we've explored them.
Sure. Shared infrastructure, virtualized resources shared efficiently, dynamic provisioning, on-demand self-service, automated resource allocation based on need, broad network access, accessible over the internet via standard protocols, multi-tenant capable, secure sharing among clients, rapid elasticity, scale up or down quickly, managed metering measured service, tracking usage for billing and optimization.
In a nutshell, sharing and scaling services from almost anywhere, paying for usage.
That covers the essence of it.
And this represents a real evolution in computing, right? Our sources show a progression from mainframes.
Yeah, it's an innovation both technologically, virtualization, enabling hardware efficiency, and in terms of IT deployment. It's revolutionized how resources and applications are provided, creating entirely new business models.
But it's not without its challenges, even now. What are some hurdles?
Oh, building truly efficient cloud applications can still be tricky. There are often imbalances between compute speed, I/O, getting data in and out, and network bandwidth. Developers still need to think carefully about data placement.
And the shared nature can cause issues.
Sometimes. Performance isolation isn't always perfect. Heavy load from one tenant could potentially impact another's virtual machine performance slightly, leading to fluctuations. Reliability is also a constant concern in massive systems. Nodes can fail.
Choosing the right type of cloud instance, balancing performance, cost, security is also critical.
Absolutely. And for complex applications running across multiple instances, ensuring efficiency, consistency, and dealing with network latency between those instances are ongoing challenges.
The notes list some specific major challenges too: security and privacy.
Still top of mind for many. Concerns about where data is stored, who can access it, provider monitoring. This sometimes leads to hybrid cloud approaches, keeping sensitive data in-house.
Lack of standards.
Yeah, while interfaces are documented, true interoperability between different clouds isn't seamless yet. Groups like the Open Grid Forum and Open Cloud Consortium are working on it, but it's evolving.
Continuously evolving nature.
The whole landscape keeps changing. User needs, interfaces, networking tech, storage options. You have to keep adapting.
And compliance.
Big one. Regulations like SOX in the US or GDPR in the EU dictate how data must be handled, often influencing deployment choices, again pointing towards private or hybrid for certain data.
Okay, let's briefly revisit distributed computing. It's the foundation, right?
It really is. Distributed computing studies systems where multiple autonomous computers communicate over a network to achieve a shared goal, dividing problems up, solving them piece by piece across different machines.
Using message passing to coordinate.
Right. It evolved from physically separate machines to even just separate processes on the same machine acting autonomously.
And parallel versus distributed, the key distinction again.
Often memory access. Parallel systems frequently share memory. Distributed systems typically have private memory and rely on messages. But there's overlap. You can have parallel processing within a distributed system. Both are crucial for the cloud scale.
Which led to grid computing.
Exactly. Grid computing emerged from distributed computing, focusing specifically on securely sharing compute and storage among dynamic groups, creating those virtual supercomputers or data repositories.
Applying networked resources to solve big problems.
Right. Sharing devices, data, compute power across organizational boundaries.
So, was distributed computing basically an early form of the cloud? The notes mention SETI at home.
You could definitely say it paved the way. SETI at home, launched in '99, used spare processing power from internet-connected PCs. That's a form of distributed resource sharing. More recently, Things like Hadoop provide platforms for distributed data processing.
BitTorrent for distributed file sharing is another example.
Yes, another distributed approach focused on storage and transfer. But these distributed systems don't always have all the hallmarks of cloud, particularly the automated instant scalability and the commercial service model.
Could you build a distributed system as a cloud, though?
Potentially. Peer-to-peer systems can resemble cloud storage, but you'd need to add layers for management, security, billing, etc. to make it a true cloud service. The cloud paradigm really built upon the foundations laid by distributed computing and virtualization research.
Okay, so wrapping up this deep dive. Cloud computing is fundamentally about getting computing resources, infrastructure, platforms, software as a service over the internet. The big draws are flexibility, scalability, and often cost-effectiveness.
Precisely. We've covered the main service models, IaaS, PaaS, SaaS, and the deployment models, public, private, community, and hybrid. Each offers different trade-offs.
And we've seen it offers huge benefits, but also brings ethical, security, and management challenges that everyone using it needs to consider carefully.
Absolutely. It's a powerful paradigm shift, but not one without complexities and ongoing evolution.
So here's a final thought to leave you with. Cloud computing grew out of distributed computing and virtualization. Given that foundation and the constant pace of innovation, what might be the next fundamental shift? What future technologies or ideas could reshape how we interact with technology, moving us beyond even our current concept of the cloud? The evolution clearly isn't over.